So it's chapter 8. This is week 10. And we are talking about wiring and losses in voltage. So this is chapter 8. Again, we'll talk about American wire gauge. So AWG is what you will see in most wires. If you look at when you buy a bundle of wire, there's always a print on the side that says AWG, and it gives you the gauge and some kind of specification. So AWG is American wire gauge. What is the advantages of copper and aluminum conductors? Most wires now are made out of copper. Copper is the standard, but there was a time when aluminum was the most common wiring.
Copper?
Yeah. Copper is the most common now, but at some point aluminum was very common. Why is that? Huh?
Cheaper. Cheaper?
That's most conductive.
It's cheaper. It's not very preferred. Copper is very much better. But the cost and also the availability.
And the production.
Yeah, availability at some point was really low during, I think, I don't know which era, the 50s and the 60s, after World War. The copper was very scarce, so they used second best thing, which is aluminum. So you might see some equipment with aluminum wiring. You can see what is the difference between aluminum and copper, but currently it's mostly copper. So I'll talk about the difference between copper and aluminum. I will talk about the differences between stranded and solid, even though they are the same gauge. And we did talk before about how resistance does change with the wire gauge and the wire length. So that's something we will talk about. Factors considered when sizing electrical circuit conductor. So what factors do we consider? Why does it make a difference? And is this something we should even look at? Again, how to correct, what is the code we use for all our standards, electrical codes?
AC.
NEC. This is going to be one of the questions in the final. So when in doubt, you always consult with the NEC. It's a website, you can go to the website and
National Electrical.
code. That's the minimum you can follow. And the state code usually is higher, the regional code is even higher. How do we calculate the voltage drop in an electrical circuit? So we understand from Ohm's law, going back to Ohm's law, which will stay with you for a long time. If we talk about the Ohm's law, voltage, resistance, and amperage. If the resistance increases and the current is the same, what happens to voltage? Decrease. So that's what they call the voltage drop. Those dots are kind of distracting.
Yeah.
Why are they even there? Problem solved. So we'll talk about the voltage drop, which is the main reason we're doing all this chapter. Voltage drop is one of the most neglected parts when we do wiring. You can buy a big bundle of wire and just expect voltage to go forever. But again, always go to the water circulation analogy. If you have a long pipe, eventually you'll lose a lot of pressure. So you cannot have infinite pipe and you have the pressure as the same. And if we compare voltage to pressure, then it should be the same. Voltage is not going to be the same for a long distance. It will keep dropping slowly. What type of enclosures for disconnect switches that are available? What do you mean by enclosures? Where's my disconnect switch? So these disconnect switches could be inside and also outside, and they could be inside a plant. So we have two types, indoors, outdoors, and we have also explosion proof, which are available usually in power plants and industry. If something happened, they will not deteriorate or break, so they have also explosion proof. What else do we have for enclosures for wire, like conduits? Like conduits, what kind of conduits do we have? This is some type of a conduit. There are wires going through it. There are plastic, there are sheathed one, there are weatherproof, there are also the metallic ones, so we need to use the appropriate ones for each application, otherwise the wires are not protected. By code, you're not supposed to have any exposed wires. Everything has to be in a conduit for protection and also so it will not be pulled and disconnected. So that's something also we'll talk about. And especially if you put the equipment outside. What equipment are usually placed outside?
So that way they're not inside the house.
No, but which one?
The big compressor.
The condenser? Condenser usually outside because it's dispensing a lot of heat, so you want it to be outside. And if it's outside, you'll also put the compressor outside, so they all come in an enclosure. So it has to be outside. Sometimes they are shaded, sometimes they are not. And if you put the wiring for those equipment, it has to be coming in an enclosure.
Also, if it's like a flat roof, they put it on the roof.
Yeah.
But if
outside.
it's actually outside.
It's outside, yes. Okay, explain the type, size, and enclosures for disconnect switches. Some of them are fusible, some of them are not fusible. If you can remember fusible and non-fusible, let's look at this one. Is this fusible or non-fusible?
Yes.
Fusible?
This is fusible. It has a fuse in each line. And if you notice, it's also three-phase. The fuse only is placed on the hot line, so we have 3 hot lines. So this is probably 3-phase. Actually, it is 3-phase with fuse on them. And if you look in here, you can look at the rating and also the approval. It's the UL approved. What is UL? Underwriter Laboratories. That's the abbreviation for UL. And that is for the people who actually test those and put codes on it, and they approve that this is going, they give you the limits. How do we use it as a maximum and minimum, and they say this is approved. And also, if you buy an electrical tape, it also has UL on it. You also can see the volts, the maximum. This can be used for 240 volts, 1 phase, or 240 volts, 3 phase. They give you also the horsepower rating. And this is indoor enclosure, type 1. Fuse, terminals. They also give you the limitation of temperature, 60 or 75 degrees Celsius. So I'll pass it along so you can look at it and see what it looks like. Make sure you skim over the label to see what information is there. How do we install breakers and electrical breaker panels? We're not supposed to be installing any circuit breakers. We install equipment from the circuit breaker to the equipment. We are not allowed to. You need a licensed electrician to do that job. If you do it yourself and it works, it's against the law. Even if it's your own house, you probably not, you'll have issues with insurance. So again, that's the common rule. I'm sure there are exceptions, but this is the common rule. So if you can remember one thing from this chapter that you want to take with you is one reason for wire sizing is a drop of voltage. Voltage drop is the main reason we need to know the proper size for a wire. Voltage drop. So, as a general rule, for each branch, a branch is a wire that you take from the main wire. Like we are connecting some wires and some equipment in parallel. So for each branch, you want the drop to be around 3% only for a branch, and usually the manufacturer recommend 10% below the nameplate. What is the nameplate? It's what is labeled on the equipment. If it says 120, only 10% is the maximum. If it goes lower than that or higher than that, probably the equipment is not going to run properly. Again, a lot of time these things are neglected, and it's something you should check at some point, especially for a new installation, or if something has been added to the equipment. Think of that voltage drop. How long is it? And when you try to install new equipment, especially for a condenser that's outside, and you have to run a long wire, within 100 yards, actually within 100 feet, it's okay, it has been calculated, and probably in the installation they will tell you, within 100 feet or 100 yards, whatever limit it is, it's okay, you don't have to do a change of wiring. What if it's longer than that? Probably you have to consult the manufacturer and see what wire you should change to. Because again, most of this equipment are rated on 14 gauge. So probably you will need to lower the resistance. And how do you lower the resistance?
Making the wires bigger?
Yeah, you increase the gauge. So we also said that which one has more resistance between those two?
Smaller one.
Small one has more resistance. Because there's more cross-section area. And again, two wires. Same size. This has less. So length, add resistance, girth, reduce the resistance. And again, think of a pipe. Bigger pipe has less resistance than a smaller pipe. So I'll repeat this at the end of the presentation to remember what is the voltage drop. For a branch, it's 3%. For the total voltage from the main equipment till the source, it should be around 10%. So when it comes to installation, there is a lot of subject involved in terms of enclosures, wiring, wire type. The panels come in different kinds. Make sure you always follow the instructions. So for us, let's think about wires. We said like small and big, long and short, and we have something else. We can get the same gauge wire. This is called stranded. Solid. So what can you think of advantages of stranded wire? Huh? Bendable, easy to bend. Let's put that down. Advantages. Easy to bend.
Easier to splice.
Easy to cut, you mean?
Easier to splice.
Yeah. What else? When you have terminals that goes around a screw or something, this has more surface area, more connection. What else is bent? What about some disadvantages?
Easier, you have to short or something?
Yeah, they can. So one of the strands can go away, can go outside, so could cause spark. You can lose strands. You use only half of them, and half you already cut. What else? They could be very annoying to work with. Put them in a terminal, you have to twist them very well.
You're even trying to put a wire knot over them. Sucks.
Yeah. But if You always have to follow the recommendation because they are very recommended in some cases. For the solid ones, advantages,
Easier to be
is
like.
to connect.
Yeah.
What else?
Was it like it holds the wires in place?
Huh? Has better connection. It's not easy to bend. It's easy to guide through a conduit because it doesn't bend as much. It's easy to cross through a conduit.
It holds its shape.
Okay. Sure, you can think about the advantages. Disadvantage. Easier to break. What else? Hard to twist around together. It's really hard to twist to solid ones. And you can think of other things. Is it possible? Well, is it possible? Is it the code to connect stranded and solid together?
No.
No. People do it, but it's not the code you're not supposed to, because again, you have different connection. And one of the problems with connecting stranded and solid is you might connect only few strands and all of them. If they are uniform, it's easy to connect. So I'm gonna put that here so you will remember. It is not the code to connect solid and stranded wires. People do it anyway, but it's not the code, just so you know. If you have somebody inspecting your work, probably they will look at that. What is the gauge we use in HVAC? Most common gauge?
14.
14?
Yep. 14 gauge. What about for control? That's for equipment. You got it. For control, 16, depending on or 18. Because they're very small and easy to connect and bend. So that's the ones that we will deal with. If you have noticed from the small connection we did, it's always good to have the right connection and the right equipment. What do we use? Skate connectors. Those are really convenient, make things much easier. Instead of you trying to put the wire in the terminal, it's not secure, you put it in a flimsy way and it comes out. It gets really frustrating. So you want to use the proper skate connector. Use connection. So we have those are called spade connectors.
I thought the one with the hole in it was
The
a
hole?
spade.
See, I'll bring the box so we can look at it. Spade connection. What about the sleeve one?
I thought that was the spade.
No, it's the sleeve. I'll show you the spade on the sleeve. The sleeve goes inside a connection.
Yeah. I thought that was spade.
I'm not really sure about the terminology, but they look different. This one has a Timber,
Yeah,
plastic tube.
Yeah, good.
And also they have the tube is connect two wires together. Press, fit them together.
Yeah, those are butt splice connections.
So again, we all have to go by the code. Again, national code governs what wire and what gauge goes into what. Copper is the most common. Again, aluminum is not really common, and the problem is that it corrodes easily, and it has a tendency to become loose, and it's not as malleable, which means it can break easily. Mostly in all equipment, you'll see a lot of aluminum. Question?
It says easy to get into a.
Conduit. Okay, I'll give you 2 minutes break to discuss wires. I will go grab a box so you can look at that.